All right, here we go, number 16. Single page display. All right. Here we go, number 16. Okay, so 16 says, snowball melts and surface area and volume decreases. The surface area in square centimeters is modeled by the equation. So S is equal to, this is page 21 and 16. S is equal to 4 pi r squared. We also know that volume is equal to 4/3 pi r cubed. Okay, it says find the average rate of change, of the surface area and volume as the radius decreases from 25 to 20 centimeters. Okay, so for both of these, what I'm going to say is that H should be 25. Sorry, A equals 25 and H equals 25. Because your starting value is going to be 25 and your ending value is going to be 5 less than that. Okay? So what we're going to do is difference quotient twice. Now after our warm-up today, these should be easy, okay? Because it's just a single, like a single squared or a single cube. All right, so I'm going to do this one first. I'm going to do my surface area in red, like this. Okay, do you guys mind if I go through this as quickly as I can? Is that okay? Fine. Go for this one right now. Okay, so what's going to happen to make the general equation? So it's going to be 4 pi e plus h squared minus 4 pi a squared all over h. Okay, that looks frightening. Like I'm looking at that. There's pi's and a's and h's. Disgusting. Okay. A plus h squared turns into 4 pi e squared plus 2ah plus h squared minus 4 pi a squared all over h. Okay, so far so good. No errors yet. Okay, which turns into 4 pi a squared plus 8 pi ah plus 4 pi h squared minus 4 pi a squared all over h. So far so good. The 4 pi a squared and the negative 4 pi a squared are going to cancel. So I'm going to be left with 8, my head is huge, 8 pi ah plus 4 pi h squared all over h. So I'm going to expand page, hopefully. So m is equal to 8 pi a plus 4 pi h. That's here, m is equal to. And that's going to be for your rate of change for the surface area. Okay. That should be somewhat straightforward. That's a lot easier than our warm-up so far. Okay. Questions about that before I continue? Okay, I'm going to do the same thing. I'm going to go back up. Hopefully that logic you guys can. I'll do the same thing for a cube. We just did a cube once. It's going to be identical, okay? So I'm going to hopefully scroll back up here. Maybe not. Oh. You can tell I don't ever use one board. I've never actually used one board in my life. So I'm going to try this way. I don't know how well this is going to work, but I'll do my best. Okay, so I'm going to say m is equal to, once again, f of a plus h minus f of a all over h. People are afraid of fractions. Don't be afraid of fractions. Just to save some digital blackboard, I'm going to write it like this. Okay, because I don't want to scroll down too much. Okay, okay, on the logic there, like so it's cube. Yeah. I apologize, that may happen from time to time today. We're all good. Now this is the time as I'm going through this stuff, I know I'm going through quickly. If something doesn't fly, please stop me. Okay, if something's not clear, because that's why I'm taking the time to take this out. Okay, So then we're going to use, do the cube thing, so it's going to go to 4/3 pi, that's going to be a cubed plus 3a squared h plus 3ah squared plus h cubed. Minus 4/3, I'm still, I go back over h. So I'm going to go. So we're still good? Haven't lost anybody yet? We're good? We're lost? Okay, so I'm gonna, I don't know how I'm gonna fit this on here. So it's gonna be 4/3 pi, oh boy.
Can't you just turn on to like a variable till the end, so you don't take out something?
You think so?
Like 1 or something?
Yeah, I don't know if I can do that.
It's a guy.
If you did that, that's fine. I don't know how this is gonna work. Oh boy. I'm gonna cheat here. Okay, I sort of cheated there, if you don't mind. Okay, I wrote that line underneath. Okay, you guys just distribute, that's all I did though, right? You guys, calculus here, we just distribute, that's all I did there, okay? And that turns into those two 8's cancel, so I'm left with.
The entire left side and shrink it?
What's that?
Couldn't you just select the entire left side and shrink it down, giving you more room?
Maybe. I don't want to get too complicated here, okay? Let's go, so we're gonna have 4 pi ah squared plus 4 pi a squared h plus 4/3 pi h cubed all over h times by 1 over h. Okay? Which turns into the slope for this should be 4/3 pi h squared plus 4 pi ah plus 4 pi a squared plus 4/3 pi h squared. Now I'm hoping somebody writes these down for me, please, so I don't have to do that again. Okay, questions and fears. That's just algebra. That's it. Is there any mistake? Oh no. What was it?
I think you wrote 4/3 pi h squared twice.
Oh, I did? Beautiful. Did I? Good. Perfect. I thought, boy, that was perfect. Thank you. Okay, that was a major mistake. That's a minor mistake. What's this in pi a squared then, right? Yeah, I'm good? Yes, thank you. Thank you. Okay, so there we go. Now, of course, the cubic's going to be more, when you take the difference quotient of a cubic, it's going to be bigger than a squared, right? So it makes sense that the one on the right is more complicated. If you really wanted to get crazy, you may want to take out the common factor of all those pi's to make your life easier, okay, which is possible to do. What's that? Are we good still or not really? Joe? Okay. Okay, I'm going to just scroll down a bit. I'm going to extend the page. Okay, I'm going to extend the page again. If you still, whoops, oh goodness, too much. If you need this, let me know. Can I trim up to there? Is that okay? Trim up to there. I'm going to do some factoring to make this easier on myself. We'll take a, what, a 4 pi? That's optional to do, but I don't like pi's, right? So that's easier to deal with that. Okay. We're good so far? Okay. So we said A was equal to 25 and H was -5. Is that right?
Yep.
Okay, so let's do this one here. On the left, so I'm going to do M equals 4 pi 2 times 25. That's 185. Is that right?
Is that H for the one that
sorry. Does that match the back of the book, or are they negative problems? Is that something they negative?
And they did the 565.
Yeah, I can't see how that'd be negative. Unless the thought is that you're dropping, but I mean, if the,
Yeah, I got positive.
yeah, because even if you started at 20 and the difference was 5, it'd still be a positive number, right? So, yeah. Let's finish this one up here and we'll be done, I hope. And H was 5.
Yeah.
Good. 25 over 3, thank you. Minus 125 plus 625. So that turns to 4 pi. Oh boy. Somebody want to save me here? 1875 minus 375 is 1500. 1525 over 3. Somebody want to save me there? Is that right? I hope. Yes. Okay, so whatever that turns into, m equals 6100 over 3, 6100 pi over 3. Okay. You guys all have calculators, I don't, so I think that's right. I don't mind leaving it in terms of pi. That's fine. Okay, what was B? B is probably something similar to that. It's an average rate of change. Oh, instantaneous rate of change. Okay, so let's just talk about what the answer be. Will the answer be bigger or smaller for a snowball, for how quickly it's getting smaller? Will it, sorry? And so when it's this big, will it be getting smaller faster or slower as when it's this big? Slower, right? Okay, because there's a lot more volume here. Okay, even if like the rate of change of the surface area of a big giant snowball is going to be getting smaller, so it should be less. Does that somewhat make sense? Was 15 like that too? 15 was like that too. Good? Somewhat okay? Alright, I'm going to start with the sorry, chapter. Yeah.
In the basket equations, do you care?
Oh, I
I
probably
don't know
should.
how they got the units.
Okay, the average rate of change is going to be what units of these? This should have been centimeters. What is this? Centimeters? What is this?
They had centimeters squared or centimeters. That's what they had.
So this should be centimeters, right? Oh, we'll leave that for right. We'll leave that for right now. Okay. Because basically what they're saying is the rate of change. The rate of change of surface area, they're saying is going to be 185 centimeters square for every centimeter of radius. Okay, that's what they're saying. Like, so every centimeter of radius changes the 180. Same thing here. This is going to be that many centimeters cubed for every centimeter radius changing. Right, because that's what the factor right is per radius. Okay. If I'm not, I won't be interested in that until we talk about applications, which is today. Okay, so. All right, let's put down I'm going to stop recording. I'm going to hit pause. If there's any questions, Peter's now's the time to ask them. Did that help clarify things, or really? A little bit, yes?